Okay. I'm Rory Ryan, Director at RYAN+LAMB Architects. We primarily focus on education, aviation, and housing. We do a few other building types as well, but that's our primary three strands of business. I've been working on MMC type projects since the late 1990s, including some prefabricated housing elements in Sillogue 5 in Ballymun, where we did pod bathrooms, precast walls and the like. And I've always been interested in offsite construction, where you have the ability within a factory environment to control the quality and output. So today's slides are really going to be about how we design early with MMC in mind. The Institute of Architects have a very helpful document called Design for Manufacturing and Assembly, and there's an overlay to the RIAI plan of work. So the plan of work, stages 1 to 8, are how an architect should run a project professionally, and how it will incorporate all elements of a project sufficiently so that the end result is correct and built properly. The DFMA overlay introduces a level 0, where you begin looking at whether MMC is applicable to the project, whether it would be of benefit before you even start design. And then that overlay introduces MMC specific information at every stage, so that MMC can successfully be incorporated, and it opens a lot of opportunity for architects working with manufacturers. So as I go through the slides here, the first thing I want to touch on is innovation and design opportunity. And then I'll go through a Muse project where we used a category 6 MMC. But I'm going to show you how we actually designed that, MMC only being a small part of the design, how we look at urbanism, conservation, environment, all of that type of thing. And then finally, as a short part, how we've taken that the resulting project and looked at it as a hybrid to increase density in suburban projects, where you might have a brownfield site and 3 and 4 bed semi-Ds going in, how we can use this hybrid duplex as well as volumetric construction to improve site times, but also increase density. Because obviously housing is very topical, and as we spread out with semi-Ds, it doesn't make a whole lot of sense. So I'll run through the 3 elements of the presentation in that way, and then we can take questions if there are any at the end. This graph is the diffusion of innovation, relates to all types of innovation. Just seeing I have 3 N's in the innovation piece there. But it's about how human beings accept new innovations. So you have the innovators over here, 2.5% are the innovators. They will actually develop, whether it's products or services or whatever. Then the visionaries are the early adopters. They're the people who start to use them. They don't necessarily create them, but they use them. I kind of believe we're around here because the mainstream market is there. We're probably somewhere here at the start. The pragmatists are the early majority, or around 34%. They're the people who see the need for it and aren't too worried about it not working. And the conservatives are late majority, and skeptics and laggards are towards the end. That's how we embrace technology. They're the early adopters, queuing for iPhones, 13.5%. And our MMC business in all countries is at this point where we need to move beyond the early adopters. And this is what I hear all the time, and I hear it disappointingly from lots of architects. They talk about prefabs. I was actually at a comedy show where they chat to the audience, and I was asked what I do, and I said part of what I do is schools, and they went prefabs and slagged me off for about 10 minutes about prefabs. But we need to move away from this idea, because the technology is so far beyond this, and we need to move to this concept. This is a concept we actually built this in traditional construction. It's properly designed to meet every standard that you need to meet for housing. But we also looked at it with a volumetric company in terms of how we would build this offsite. So it's a very real opportunity. When you look at the breakdown of a building like this, anybody who's familiar with volumetric will see where the seams are going to be. It can be about tidying away those seams, eliminating the look of offsite construction, the detailing of how you do windows, how you do sills. The technology is there, and it's for designers to get in there and look at this afresh. Ignore the fact that it's offsite construction for starters, and look at what we can do to detail the buildings as you would in traditional construction. So moving on to the Muse project, this is exactly what we did for this project. The contractor and I visited an IFC company down in Kerry in 2014. I'd seen a lot of stuff about IFC. I did a bit of research and found there was a company down in Kerry working away. At the time, it was pretty bleak in terms of construction. We're still coming out of the recession. And when we went down to look at what they were doing, we saw how a block module could work really well. But it comes back to early design. So 6 years later, he had bought this site, and he approached me and said, look, I want to put a house on this. I think it could take two. So let's get going. So we began with ICF in mind. So this will show how we did the ICF. It'll show that we used categories, the various categories we used. It'll track how we designed the Muse house itself, show you the tight urban constraints, look at how we designed that, but also how ICF assists in that construction, and then look at the how we look at higher density thinking after this. So one of the biggest challenges beyond the urban infill and the construction methodology was looking for a three-story development. It's primarily single-story and two-story, and it has protected structures in the vicinity. We wanted to get two residential units and had to look at this multiple range of constraints for the project. So this is in Clontarf. Fairview's over to the right. This is the Crescent where Bram Stoker, who wrote Dracula, was born. This is the Crescent Park, and this is Crescent Place here. So it's a small, you can see it's a small Muse, and there are 12 original cottages here, which were built in the early 1900s. And then you can see all these little pop-up houses, Muse houses of various different types and qualities, and a number of industrial or light industrial sheds and car garages and all that type. Very typical of any Muse lane you might find in Dublin, Limerick, or Galway, or any of the cities. So that's the site there. It was a single-story shed at the rear of this protected structure, which is quite an important piece of the planning process, because protected structures have what's known as an attendant grounds. So if you look at this one here, this is the original garden of that protected structure, and a conservation officer is following the Planning and Development Act 2000, can query the appropriateness of structure within the attendant grounds of a protected structure. A couple of photographs from ground level, so you can see the little flat roof there with a roller shutter, and then it's a pitched roof at the back, and some of the variety of different houses all along. So this was our design concept, to do something very contemporary, and match the environment in a way that I'll explain through some other slides. So the first thing we had to do is look at the history of the area. That's a view of the Crescent, probably back in the early 1900s. So you can see all those protected structures there. Up the road is the casino and marino, which is a 3-story folly, I suppose you could call it. It looks like single story, but there's a basement and 2 stories there. Very much worth visit. The Crescent was built out of spite, to block the view of this building, the view of the sea of this building. So I think that's quite a humorous little piece of history. Developers having a rows in the past. What we had to do, so the attendant grounds that I talked about was really important. So we went back in mapping to pre-1900 and found there was a building called Merino Lodge here, and this was their access into the site. And why is that relevant? Well, it actually helped us to show that the site in question wasn't part of the attendant grounds. So we overlaid the red line, we extracted a red line of the old Merino Lodge, and we imposed it on mapping from 1913 forward. So that's the 1913 construction. So then we went to overlaid it on the satellite view from 2020, and we'll see this shed was just edging past the red line there. That's our site. There's mapping from 2020. So what that allowed us to argue was that the site itself wasn't part of the attendant grounds originally. Maybe a little part of it was, but the majority of it wasn't. And that took away a substantial argument from the conservation side. So then what we did was analysed what has happened over time, and we looked at the various mews houses that have been built, and you could see that there's really sort of an offset building line beyond which any more contemporary structures haven't transgressed, and the existing shed there does transgress, as does the next door, which is still there. So the idea was that we would remove that part of construction. Well, removing the whole lot, but there would be no construction in that location. We put a new garden in there. We've moved back to this, I suppose, somewhat well, it's somewhat defined building line. It's an extent of building line, I'd say, and that was how we first began our strategy for where we would build the house or the units. So this is a Revit model of the project, which I suppose I'll just touch on briefly. We working with MMC. You've got the McLeamy curve, and you've got to use BIM when you're working with MMC. Otherwise, you'll probably run aground in terms of coordination. So we built up the existing fabric to get a really good sense of what the actual volumes of buildings are. You may know about cloud point surveys, point cloud surveys, where you survey digitally all the actual building volumes, and it's really useful to get exact heights and volumes so you can actually design to those volumes. This little butterfly roof here actually helped us out quite a lot, as did some of the other structures, because that gave us a high point to work off to get the third story in. So we developed the design, and what we've done is we've actually dropped down half level at around the center of the building, and there's a unit. Unit one sits up here, which is a two-story one bed with two terraces at the front. This is a common access. There's a garage here that connects into unit two. That's three-story, but it's pushed down by half a level. So we look at the proposed form of the development, and in any planning for Muse developments, the planner wants to see how future integration will happen. So you do a little master plan, and if it's quite feasible that these sheds will at some point become houses. So we looked at establishing that front facade there. So that's what informed our first facade, and then the rear facade is there, and this front facade also screens the rear facade. So, maybe a few photo montages. So that's the existing and the proposed, and you can see the building line begin to take shape along here. And similarly, that's the existing view with the proposed view. And it also gives you the opportunity to animate the facade. In our final design, we've actually a recess here, so you can stand into a porch area, covered area, while you're waiting for or get your shopping out of your car, whatever it may be. And then you can see the screening. All of these elements are done to eliminate overlooking from existing properties, but also to allow high quality light penetration into the building itself. So a big window here had the potential for objections from neighbours that it's looking in on top of somebody. So by having no window there, we have a space for a bed, but we have a window wrapping around it in an L shape behind that balcony, and then you've got a screen balcony and lots of sunlight. This is west facing as well, so it gets really nice sunlight in the evenings. And then the screen here is purposely it's purposely transparent. The idea is to allow light through, but also to give a certain level of passive security onto the street, and then light through for growing plants in a quite a generous terrace. So this one bed would be well above the standards for a one bed. It's about 65 square meters, whereas the standard for a one bed is 45. And these are the 3D model views. Because we had this done in BIM, then we were able to take it through to rendering packages and produce these images for planning stage. There's the cross-sectional analysis. You can see the relationship with the protected structure, and as it scales up and back down to the relationship with the single-story cottages on the far side of the road. So we commenced work with using the ICF construction. It was quite interesting talking to the developer during the process. It was his first time using it, but he noted how much of a straight line he could get compared with block work. He was able to deliver all the insulation onto the site, store it on site quite easily, and build around. He's a joiner. He's a carpenter himself, so his preference was to build the floors using timber, which is an option. That's really a cost-saving thing for him. I quite like the ICF with beams with screed as well, but this was his choice to do this. So he built the whole structure himself. he had minimal need for supervision. In his first run, he did bracing at meter centers, and his second run he improved that to or shortened that to 800 because he felt it needed a little bit more stability for the concrete pour. I think this is a good example of how it was quite tidy to get the concrete pump in there. So you can that's the roadway there. He agreed with a neighbour to put a cone over here to keep a car parking space free. Was able to get the concrete pump in quite tight to the building, and do his various pours without disrupting traffic in the Mews lane. So that's you can see the steel work and his timber infill. He left a hole in the middle of the building. I was on site one day and asked him why there was a hole in the stairway, and he said that's where I'm bringing my steel through. So he's quite competent in knowing how to build, but he was very. I found this really interesting that he really didn't have to do a whole lot of adaptation to use an MMC category. For him, it was very similar to block work and quite a seamless transition. So now he's quite encouraging. Anytime we give him something to tender for, he's always looking to see if he can use ICF, and it shortens his time on site. And he's very adamant that it gives him a higher quality than block work with let's say insulated cavity walls. So there's a photograph with some of the windows in, and the rendering layers are progressed. You can see the upper level courtyard there prior to the screening going in. And that terrace is a substantial terrace with a single sliding door. Well, the both panes can move, and you've got kitchen, living, dining on that level, and that's a full bedroom suite up there with a study area. So it's quite a generous apartment. And these are some of the photographs of it as on site. That's the master bedroom at the back, ensuite in behind there, with a nice terrace. Plenty of space over here for a sofa or a work from home desk. That's a view from the rear garden, so it's stepped down. He's built a little swimming pool there, which is yet to be filled, and there's a little recess here for a sofa. You can see the 3 levels there, so it's quite discreet in terms of its environment, and not as imposing as it might sound when you come from the view that it's a 3-story in a predominantly 2-story Mews area, and that's one of the views of it almost finished. So we then looked at that while we were working on a larger housing development. We looked at this as a hybrid, and how would this work as a suburban typology? Because when you work in a very tight Mews environment, you have to innovate to get a design that's going to work. You want to get a design that the client is happy with. You want to get a design that the planners and conservation people are happy with, that's buildable, that looks good, that adds to the environment. So you've so many challenges you really have to work and innovate to achieve that. And when you work in a brownfield site, you don't have all these constraints. And often what we do is plonk down the 3-bed house with the standard front and rear garden, roads, footpaths, and so on. So we started to think about this as a hybrid, and how would this look in a suburban environment? And we look at the density that you achieve per hectare. It's generally 37.5 for semi-D housing, front garden and parking, private open space to the rear, and traditional road and footpath. So if we look at the hybrid duplex where you have 2 units, you're coming up to circa 70 units per hectare. You can have combinations one beds, two beds, and three beds. You can go to four bed as well, but you can combine different hybrids in this environment. You also can make provision for small retail or office units, so that where the garage area is will be located here. It's possible to convert those into units. They could be creches, there could be a little coffee shop, there could be office to rent, that type of thing. You'd also look at shared surfaces for modified and remote parking, and create one-way streets to reduce not only construction costs but actually the amount of land that two-way roads are taking up. And then you're providing private spaces within the actual building itself, which I've illustrated previously. So, and you're getting a diverse housing type. So that's a project where we're at early design stage, where we're looking at the brief is to look at traditional housing. So your density is somewhat limited by that. So we talked to the client about looking at the hybrid. Now we're at this site is at a zoning stage, so it's quite embryonic. But what we've done is looked at, if we took a section of that and used the hybrid and used 3D volumetric, how can we improve that density? Well, it's simple. You bring that hybrid across, you get diversity in terms of the units. So some might have a one bed and a three bed, some might have a one bed and a two bed. But you create a different street structure. So you make a pedestrian street to the front, and you have your parking to the rear, and you've access through the gardens at the rear to this unit, or you may have a side passage that connects you into two of these units via the stairs. And then you get a more dense environment, but you also get you also get a more friendly and vehicular-free environment. We don't think it would work on every street, but we think it would work on some of the streets, and it's about improving that density, but also improving the environment. So, for example, if you're living here, you might have your three-bed house with your garden out the back, and maybe your mum or dad is living here, or both of them in the one bed. So they can also have that family environment, but you have a separation, and then you have a space out the front where anybody can walk or run without, being worried about running onto a street, or the vehicular environment. So this review is the rear. So this is where you have your parking and access from the rear of the dwellings. And that's some of the street views. We also look at separating the access. So you could have combined access through here, or you might just bring a stairs straight up. That helps with compartmentation for fire as well. Then we have some of the internal environments. So that's the one bed unit looking onto the terrace, showing the concept we have there. You're going to get light and privacy at the same time. This was the design concept from the earlier construction photograph we showed. It's built now, and the only difference out here is there's an outdoor bath and a standing shower, and it's as private as being indoors. And this is the original concept for the lower level, where he's put in a pit there and a pool over there. So that's our thinking when we come to MMC. It's not just about the engineering of the construction of the buildings. It has to be about the design and weaving them together. Embracing MMC early is absolutely key. That's when we can influence cost and design most. Take the constraints of what we've learned in the more constrained environments and bring them into the suburban to create higher density and higher quality housing environments. and then build them in factories to a very high MMC standard, where we can also control BCAR, and we can also have, for example, you can have video feedback in time to see every single component right back to when it starts being made, and we can see the quality of every element as it's produced in the factory environment. So that's it there. If any questions.
Thank you very much, Ryan, Rory. That was great, very interesting, especially from I suppose, a residential perspective. That obviously a lot of talk around housing and the challenges around meeting delivery targets and how sort of offsite and MMC solutions can factor into that. So I'll just throw it out. I put it into the chat there, and a few questions in. Well, I'll just throw it out in case anybody didn't see the message. If any questions, just drop it in. And I'll pick it up and I'll ask Rory directly. There's a few in here already. Get the ball rolling. So we'll give ourselves 5-10 minutes and then we'll close it out. So the first one in, Rory, was sort of a practical or a logistical one in relation to the ICF project. It was around obviously ICF is dependent on the concrete truck to get in to pour the walls in situ, and in urban settings this can be a challenge. Was that a particular challenge in terms of managing the logistics of that?
No, it was. I think we were fortunate in terms of that particular location on the Mews Lane. It had the Mews, the roadway, which is about 4 meters. It had another 2 meters for a parked car, and then about 2 meters on his side as well. So he managed that himself. He was very friendly to the neighbors, and he really just got them to agree that he would do that, give them plenty of warning, and so on. We did a project a couple of years previously with the same contractor on Wellington Mews, where there was literally no space like that. There was a 1 meter footpath and a 3 meter roadway, and lots of people who were very adamant that they had a right to drive down that roadway. So that was quite challenging. I suppose it's very site specific, and in that situation, we had to get a couple of road opening and closing licenses at particular times. But I would say you have the same challenge with blockwork deliveries. You have the same challenge with, say, concrete precast slabs.
Yeah.
You have the same challenge with lots of materials. And the concrete pump was reasonably quick. What was a real relief to that project, if you look at the flip side of it, was the ICF was in and out or delivered into the site within minutes because it's not heavy. They had the option also to walk the ICF down the road if they needed to, because it's not heavy. And there was very little construction noise because of the ICF. So I think it's a really good question. It is very site specific how you get on, but whilst there may be challenges with a concrete truck, there's also the advantages of the lightweight material.
Yeah, and she says at the end of the day, materials have to be transported irrespective if it's a concrete truck or a block lorry hayab. Let's see here. We've one in here from Andrew. I'm just going to read it out verbatim. Presumably, reference to ACD's Part L compliance is not possible when utilizing MMC. Presumably, thermal modeling is typically required. Okay, that's quite a technical one. If you want to try and jump on that, Rory.
Repeat it there for me.
So it's reference to ACD's Part L compliance is not possible when utilizing MMC, presuming thermal modeling is typically required. So Andrew, if you want to jump on, if maybe I didn't relay that properly, if you want to add a wee bit more to that, I'll invite you to join in.
Hi there. There's typically traditional construction, in order to show how the project is in compliance with the Part L, designers would say that their reference point is the ACDs, and the construction is matching the ACDs, so therefore they may not need to necessarily provide additional thermal modeling, especially if building control issue an S11 on that topic. I'm just assuming that when you're using MMC, then you would have to thermally model the junctions and all the rest of it, just in case a query like that did arise.
Yeah, that's a good question. From memory, we did get a thermal model from the ICF company. The thing with all the junctions is that all the construction was done such that there's no cold bridging. So it was very simple to detail, and my memory is we got a thermal model done in any event. I don't know all your abbreviations there. Is it a section 11 you're saying?
A section 11, it would be a query that
Yeah.
building control would issue.
Yeah. So I think you called
when
it
comes to
S11.
MMC, they might be tended to ask a question in relation to, whereas they wouldn't with conventional construction, you know, even though the MMC actually might be performing better, but then they want evidence to demonstrate how you're verifying that.
I think you called it an S11. I just wasn't sure if it was section 11 you were referring to. Yeah, I think building control are, the challenges to MMC are all of these. What building control do have concerns about it. There are a lot of, for example, modular or volumetric companies that are just achieving their agreement certificates. A lot of the MMC comes with Part L testing as part of the system. But I also I've seen queries from building control and through section 11s, and even at fire cert stage, querying the build-up and how that works. And there definitely is a lot of challenges there. Even in things like you look at an elemental piece of 3D volumetric, and I had a fire officer query that it was an element, whereas his worry was that as that single element wasn't complying with Part B, whereas the manufacturer was arguing that that element on its own isn't what's to be analysed. It's the build-up of the entire construction. So it is challenging, without a doubt, Andrew. But we haven't had challenges that would be beyond traditional in section 11s or dealing with building control.
Okay.
Thank you.
Thanks. Rory, you've your law of Suez there, if you want to jump in. That's hand up, Anna, just ask you in case you're wondering what I'm blabbering on about.
Yeah, thanks. Thank you. No, just to answer the question on the Part L and the thermal modelling. I'm with a 3D volumetric company, a Modulac down in Limerick, and you could reference the ACDs, but we use predominantly a metal cladding on our building. So if we were to use those, we would have the values that we would achieve would be going into the model would be less than what we're actually achieving. So we have done the thermal modelling on all our junctions, which are then given to our Part L consultant. So when he's doing his BER, he's assessing the whole, when he's doing his report, he's assessing on our thermal modelling to get to achieve the building rating. So just on that, most modular companies would have done the thermal modelling, because we are generally achieving above what's the backstops, And sorry, now just to answer another question from Stephen there on the 3D volumetric, and apologies, Rory, Ella, on this if I'm jumping in across in your response to this, but
same name, you're grand, keep going.
Yeah, from the Muse layout that Rory has shown there earlier in his project, it is something that would be possible as 3D volumetric, but the access for a crane and delivery would be your biggest concern, really, apart from that. we'll build a nuance in 3D volumetric, you know. So.
Okay, thanks very much, Rory. I have a question from Adrian in Oxford, UK. You're very welcome, Adrian, from joining us all the way from Oxford. So it's around sort of the offset between design and, I suppose, scale and volume from an MMC perspective. So I think, to paraphrase Adrian's question, so if a volumetric supplier was able to offer significant cost savings on a project, but it may compromise or impact on the initial design, would you still be comfortable doing it? Or what's the give take on that, and from a design perspective? Because this is sometimes I suppose the trade-off that's talked about in terms of design at an architectural level, and sometimes the limitations on MMC, essentially volumetric.
Yeah, I don't think we should start from a position where we're compromising. And I you know, in any project where we're doing, for example, if we're designing someone's new house, I've frequently had a question: should we leave out? You know, they're worried about cost, and they say, should we leave out something? And I say, no, we'll design what we want, and we'll then price it. And if you cross that bridge with value engineering, we'll do that. I believe that if we begin to design and compromise from the start, it's going to be a failed solution. So that's why in DFMA, the overlay to the RIA plan of work, you're investigating MMC at a very, very early stage, and the benefits of that are enormous. You're also you've got the goal of locking in your costs at an earlier stage, and much less opportunity for change to happen, because you're dealing with a system. So it's about, as designers, our skill set, what do do architects bring to this whole process that engineers don't? The engineering of it is vital, but a lot of these systems are engineered systems, and engineers by their nature are concerned with engineering. The architect, it's his or her job to take that engineering system and create spaces, and create good spaces with good quality light and good connections to gardens or open space or whatever like that. So I believe if we compromise at the start, we're not understanding what MMC categories we're using, or what what it is we're trying to achieve. And it may be at stage 0 you find that MMC is not suitable for your project, and then you move on. That would be my philosophy and approach to it.
Okay, and I suppose to lean into then, I suppose that at a national level, it's not just in Ireland, it's in essentially most developed countries that are struggling with population growth and housing supply. So we all know the numbers, so don't need to rehash them again in terms of the gap between current delivery and targets, not just this year, but the next decade and beyond. And it's significant, and there needs to be I suppose a fundamental change in terms of how we design and build housing at scale to meet that. From your perspective, Rory and Ryan and Lamb, like what would you like? Obviously, you're an advocate for MMC and innovative methods of build, and not sort of loyal to any one system. Where do you see the biggest opportunity to make that significant step change at the design stage that could sort of unleash the potential? Because there is capacity in a lot of the MMC suppliers that are out there. A lot of them are on the call today, but it's not feeding into them in pipeline, and they're all crying out for that. So from your perspective, like, what are the sort of the levers that can be pulled at a design stage to really move the dial?
I think there's what I've always looked for is if you just take volumetric, for example, there's a school being built next door to me. It's traditional construction, and every day I look at it, I think that would be so much quicker. Probably the same in terms of cost, but it'd be so much better to do that in volumetric. And I wonder why it is not being considered. If you look at schools, for example, the off-site stuff is kind of a dirty word, and there's a lack of understanding there. If I look at housing, I think what's being produced would benefit. This is sort of to answer your question better, Dick. It would benefit for designers to look at prototyping with manufacturers. So because we're looking at engineering functions, if you're really strict about it, in a factory environment, it's an engineering function that we're looking at. I was in a factory in Roscommon last year, and the technology that I saw there is fantastic. And they literally have a conveyor belt where they build a house and out it goes, and it's for their houses for the prison service. And all of the details and forms that as an architect I'd like to achieve, they can achieve. So I think if we prototyped in every factory or every MMC manufacturer, if we got in there as designers and prototyped more, we would start to see the types of housing that we want to come out of. And it's like it's about not looking at a building and seeing a prefab. Or seeing the bones of a prefab. It's about looking at a building and not even for 1 second thinking, what was that made out of? It should be seamless. It's construction technology. So when if you look at a century ago, the Bauhaus, Le Corbusier, Mies van der Rohe, they built buildings from reinforced concrete that were unbelievable. Like the Barcelona Pavilion, if anybody's been there, it's an amazing building. But that technology was there since the mid 1800s. And it was only in the Bauhaus movement where it was explored by designers and innovated. And that's where we are now with MMC, in my belief.
It goes back to your earlier slide, that diffusion of innovation. That's a personal favourite of mine when we're doing offsites with clients. But it's that there are some people who will be that innovator, take that chance first, but it's only until you do that or somebody else does it that it's proved that someone else have the confidence to do it. But it takes somebody to take that first step, and you're seeing a lot of that, and that we're a long way on that curve compared to 5 years ago. So I think, that has to be a constant. You have to be going out there to look and try and invest and support these companies, because the problem is, as you know, not to get into other conversations, without that pipeline, because of the capex setup and costs to keep these factories going, they don't have the pipeline. If they don't have the turnover, they struggle to be a long-term entity. Adrian, I'll let you jump in there. Just take your camera, or take your mic off.
Thank you very much. Yeah, no, I totally agree with you, Rory, about prototyping. I was thinking about, you showed that image of where you projecting your design over maybe, I don't know, 20, 40 or 50 houses, and wondering that it was that refined debate about mass production and volumetric and architectural design. That was really where I was heading on that question. But thank you for sharing your thoughts about prototypes. Yeah, totally agree with that.
Thanks, Adrian.
Okay, I'm going to start wrapping it up. Rory, have you any final passing comments before I close proceedings?
Yeah, I think my takeaway, or the takeaway, I think, for the industry is we need to move away from this notion that these buildings are somehow inferior. And I think the design and the aesthetic of the building has to improve. I think the technology is there. There's certainly challenges in terms of building regs, fire being a key one, but they are solvable challenges. I think the biggest challenges in the industry is accepting this technology has huge potential.
Yeah, no, I can't but agree with that, and I think that's a growing sentiment in terms of, and again, from a numbers point of view, to bridge the gap. It's not be a nice to have, or it's something that must be embraced, because, as I say, the divide is so big. We have to look at other ways of doing it. Listen, all I can say is thanks very much to Rory and his colleagues in RYAN+LAMB. Very interesting to get an insight from a design perspective on the MMC challenges and opportunities that are there. Again, thanks to everybody that attended. Again, strong turnout again today. I think our next session is from Capcon, so slight change of topic. So global specialist in sustainable rainwater management. So one of our newer MMC Ireland members. So the date will be sent out. You're all on the mailing list now, so keep an eye out for that and register early. And please don't be afraid to pass on the registration link to any colleagues that you feel would benefit from that as well. So listen, again, huge thanks to Rory and everybody that joined in, especially those that came from overseas, and to Anna as well from MMC Ireland. So thanks very much, everybody, and we'll see you at the next one.